Intro: the shocking 250% brightness increase of Betelgeuse. Betelgeuse, the star positioned on the shoulder of Orion's mighty warrior, has been displaying unusual patterns of activity, sparking excitement over a rare, potentially once-in-a-lifetime cosmic event. Some experts propose that this increase in brightness might indicate the star's approach towards a supernova. However, the precise timing of this event remains unclear, and experts suggest it could happen in the not-too-distant future. Let's delve into the present state of this star. If you wish to stay updated on the latest news from the universe, including all its mysteries, consider subscribing to our channel, liking this video, and activating the notification bell. Even if you haven't personally encountered it by name, you've likely seen the dazzling Betelgeuse, a brilliant red star that gleams in the constellation of Orion. Betelgeuse is a truly spectacular sight. Currently, Betelgeuse is an extremely massive star. If we were to place it in the center of our solar system, its surface would extend beyond the orbit of Mars. This enormous and easily visible star continues to captivate observers because it is relatively close to our galaxy. Betelgeuse undergoes noticeable changes, fluctuating in brightness. This is typical of semi-regular variable stars, where the brightness may shift dramatically as they approach their final collapse into a supernova explosion. Recently, Betelgeuse has been even more intriguing due to sudden and unexpected changes in its luminosity, a phenomenon that remains perplexing. Though its strange behavior was already unusual, it became even more captivating due to the great dimming event that took place between 2019 and 2020. During this event, the closest red supergiant star to Earth shone twice as brightly, lighting up the early evening sky in the southern hemisphere. This abnormal behavior from one of the brightest stars in the sky has granted scientists an extraordinary chance to observe Betelgeuse's rapid transition from brightness to dimness. In more recent times, Betelgeuse has exhibited increases in its brightness of over 50%. On May 20, 2023, a Twitter account named BetelBots, dedicated to tracking the star, reported a remarkable 142% surge in brightness, citing information from the American Variable Star Observing Association. Andrea Dupree, an astrophysicist from the Harvard-Smithsonian Center for Astrophysics, notes that Betelgeuse is now ranked as the 7th brightest star in the night sky, moving up 3 positions from its usual spot at 10th. In the southern hemisphere, it's quite easy to spot Betelgeuse glowing at dusk, and even in the northern hemisphere, it can be seen as the nights grow longer. A researcher from Swinburne University in Australia emphasizes that Betelgeuse offers one of the most fascinating opportunities for scientists, observing the final stages of a massive star's life in more detail than ever before. This allows astronomers to gain significant insights into what happens to red giant stars just before they explode as supernovae. There is speculation that Betelgeuse might become so luminous that it could even shine during the day, casting shadows at night. This remarkable behavior has captured the fascination of both professional and amateur astronomers alike. Eventually, Betelgeuse will meet its end in a spectacular supernova explosion. From our location, about 650 light-years away, we will have the rare opportunity to witness this cosmic phenomenon in real time. Heidi Morris, a scientist at Los Alamos National Laboratory and president of a local astronomy club, shares that people have long been captivated by Betelgeuse, closely monitoring its changing brightness. Astronomers have known for a long time that Betelgeuse experiences cycles of intense brightness followed by periods of fading. This cyclical pattern was observed even by ancient Australian Aboriginal and Greek cultures. What is Betelgeuse and why is it so important? Betelgeuse's brightness cycle spans about 400 days, but recently it has been fluctuating much faster, around every 130 days. Andrea Dupree, who has been studying the star, points out that this accelerated behavior began in 2019 after Betelgeuse forcefully expelled parts of its outer atmosphere. These brightness fluctuations are highly atypical for Betelgeuse, raising the question: does this suggest that the star is on the verge of exploding into a supernova? According to a study co-authored by Dupree and scientists from Harvard and the University of California, Berkeley, it is predicted that it could take 5 to 10 more years for Betelgeuse to return to its normal cycle. The paper states that Betelgeuse has not been the same since the Great Dimming event and has exhibited distinct changes in both its luminosity and radial velocity. Despite the unusual behavior, Betelgeuse still has a long journey before it will eventually undergo its supernova transformation. As a red giant, Betelgeuse goes through a series of fusion processes that involve elements such as helium, carbon, oxygen, silicon, and iron. The immense pressure in the core of the star allows helium to fuse into carbon, after which the star continues fusing carbon and helium to form oxygen and so on, producing heavier elements like iron and silicon. These fusion reactions will eventually cause Betelgeuse to collapse under its immense gravity, which could lead to the formation of a black hole or neutron star. Could this be the precursor to a supernova? Current observations of the chemical makeup of Betelgeuse's atmosphere indicate that it is in the early stages of this fusion process, specifically fusing helium into carbon in its core. A rapidly evolving star, Betelgeuse has led an intense, fast-paced life. As it nears the end of its accelerated evolution, it will eventually exhaust its fuel, and the core will collapse, leading to an explosion so massive it could outshine entire galaxies. While the occurrence of a supernova is inevitable, the exact timing remains a subject of debate. Despite much speculation about when Betelgeuse might explode into a supernova, there remains uncertainty. Peter Brewer, an astronomy professor at the University of Portsmouth who specializes in supernovae, has written a book on the topic. He highlights the fact that we currently have no reliable way to predict when stars will explode. Therefore, there's no clear indication of when Betelgeuse will meet its explosive end. This uncertainty is understandable as throughout human history, there have been very few supernovae observed in sufficient detail. Given this lack of certainty, we still don't know if any of us will live to witness the awe-inspiring explosion of Betelgeuse. In the grand scheme of stellar evolution, the life cycle of stars like Betelgeuse offers an exceptional opportunity for astronomers to explore the very final stages of a star's existence. Understanding these stages is crucial, as it brings us closer to comprehending the complex processes that govern the death of massive stars. What scientists are saying about this phenomenon. Betelgeuse, by virtue of its size and proximity to Earth, serves as an unprecedented living laboratory for such research. Stars like Betelgeuse begin their life in a relatively calm and steady state, fusing hydrogen into helium in their cores. This process continues for millions of years, but as the fuel runs out, the star undergoes significant changes. For red giants like Betelgeuse, this involves the expansion of the outer layers, and the star enters an unstable phase where it begins to pulsate. This expansion is so extreme that it can cause the star to grow to many times its original size. Interestingly, the changes we are witnessing with Betelgeuse in recent years are part of this natural cycle. The star has begun to behave unpredictably, with variations in brightness that seem to happen more frequently than expected. These fluctuations provide a window into the complex processes occurring within the star. The causes behind these sudden shifts remain under intense study by astronomers. Some believe that these changes may be connected to the movement of dust and gas in the star's outer atmosphere, which could block and reflect some of the light it produces. Others suggest that the core of Betelgeuse itself might be undergoing more intense fusion activity, which can cause significant changes in its outer appearance. The phenomenon of pulsations is particularly fascinating. Pulsations occur when a star's outer layers expand and contract over time, a process that results in the varying brightness we see from Earth. In some cases, this can even cause the star to become so dim that it briefly disappears from view, only to reappear brighter than before. Such pulsations are a key feature of stars like Betelgeuse and are instrumental in predicting their eventual fate. The future of Betelgeuse and what's next for space exploration. The mystery of Betelgeuse's accelerated pulsations in recent years adds a new layer of complexity to our understanding of red giants. As for its eventual collapse into a supernova, Betelgeuse is not yet at that point. There are still many stages it must go through before the final explosion. Once it exhausts its helium fuel, the core will begin to contract further under the pressure of its own gravity, causing temperatures to rise dramatically. This will lead to the fusion of heavier elements such as carbon, oxygen, and silicon, which are necessary for the creation of a supernova. The buildup of these elements will eventually lead to an instability in the star's core, triggering a catastrophic collapse and the eventual explosion that we will witness as a supernova. Despite the inevitability of this cosmic event, there are many uncertainties that remain. The exact timing of the supernova remains unknown, and much of the speculation about when it will happen is based on theoretical models of stellar evolution. Experts can only make educated guesses using the data from Betelgeuse's current behavior to extrapolate when its final collapse might occur. Some suggest it could happen in the next few decades, while others believe it could take centuries before the star finally reaches the point of no return. Regardless of when it happens, the explosion of Betelgeuse will undoubtedly be one of the most spectacular events in our galaxy. A supernova is an intense and dramatic event that releases an enormous amount of energy. For a brief moment, the star will outshine the rest of its galaxy, providing a beacon of light visible across vast distances. This event will not only be a captivating spectacle, but also an invaluable opportunity for scientists to study the mechanics of stellar explosions up close. The unique behavior of Betelgeuse has already prompted collaboration among astronomers around the world. With the use of advanced telescopes and observational techniques, scientists are able to track its changes in real time. These observations will help refine our understanding of stellar life cycles, including the final death throes of red giant stars. Even though we are currently unable to predict when the supernova will take place, the ongoing study of Betelgeuse provides insights into the types of stellar evolution processes that lead to such a dramatic end. As a star that is so massive and luminous, Betelgeuse also plays a crucial role in the larger cosmic picture. The materials released during its eventual supernova will be scattered across the galaxy, contributing to the formation of new stars, planets, and other celestial bodies. These stellar explosions are responsible for enriching the interstellar medium with heavy elements, which are essential for the creation of life as we know it. In a sense, Betelgeuse's death will pave the way for the creation of future generations of stars and planets, continuing the cosmic cycle of life and death that has shaped the universe for billions of years. As we continue to monitor Betelgeuse's behavior, one thing is certain. The cosmic events unfolding in its immediate future will leave a lasting impact on our understanding of stellar evolution. Whether we witness its supernova in our lifetime or not, the observations we make now will serve as a crucial foundation for future astronomers and astrophysicists. Betelgeuse, in its final moments, will provide invaluable lessons that will help unravel the mysteries of the universe for generations to come. As Betelgeuse undergoes these changes, it presents astronomers with an extraordinary opportunity to observe a massive star's evolution from a relatively close distance. The star's behavior provides insights into the life cycle of stars that are similar in size and composition. These observations are particularly valuable because they allow scientists to study the processes that occur just before a star reaches its dramatic conclusion. The knowledge gained from studying Betelgeuse could be used to understand other red supergiants that might undergo similar transformations in the future. The significance of Betelgeuse's behavior extends beyond just the scientific community. As one of the brightest stars in the sky, it has captured the public's imagination for centuries. Betelgeuse continues to surprise astronomers with its unpredictable behavior. The study of the star offers a unique window into the life cycle of massive stars. One of the most intriguing aspects of Betelgeuse is its size. As a red supergiant, it has already expanded far beyond the size of our Sun. If placed at the center of our solar system, its surface would stretch beyond the orbit of Mars, potentially engulfing the inner planets, including Mercury, Venus, Earth, and Mars. This immense size makes Betelgeuse a fascinating subject for understanding the physics of star expansion and contraction. Despite its vast size and mass, Betelgeuse is nearing the end of its life cycle. It has already burned through much of its hydrogen fuel, transitioning to heavier elements in a process known as nucleosynthesis. As a result, the star has expanded and cooled, giving it its characteristic red hue. This transition marks the final stages of the star's life, where it is no longer stable and begins to experience the rapid fluctuations in brightness that have captured the attention of astronomers around the world. The pulsations we observe are a reflection of the turbulent changes occurring in the star's outer layers. In recent years, the variability of Betelgeuse's brightness has sparked new theories and discussions about the mechanisms driving these changes. While some researchers speculate that the brightness fluctuations might be linked to changes in the star's core fusion activity, Others believe that the star's outer layers could be unstable, causing significant mass loss. The sudden ejections of material from Betelgeuse's outer layers, observed during the dimming event of 2019 to 2020, provide additional evidence that the star may be undergoing some form of transformation that could eventually lead to its explosive end. As we look ahead, there are still many unknowns about how Betelgeuse will ultimately meet its fate. While the exact timing of its supernova remains uncertain, one thing is clear. The explosion, when it occurs, will be a spectacle of cosmic proportions. It will not only mark the end of one of the most iconic stars in the sky, but it will also serve as a profound event in the study of stellar evolution, offering scientists a rare opportunity to observe the death throes of a massive star up close.